today's topic is 5 logarithmic functions. Today's date is today, and our objective is to define and apply logarithms. I'm sure right about now you guys are all wondering, gosh, I wonder what a logarithm is. It's kind of the inverse of an exponent. They kind of undo each other. Kind of like how addition and subtraction can undo each other, logarithms and exponentials can undo each other. So here is the math speak of the definition of a common log, and then I'll talk a little bit more about what it really means. So a common log, the exponent you get when you write x as a power of 10. So the log x equals a if and only if 10 to the a equals x. In a minute, we're going to talk about different types of logs, but if no base, and what that means is no little number right there is given, I just wrote in a 10, it's assumed to be a common log, which means its base is 10. Well, I can rewrite 10 with an exponent, so that means the log of 10 is 1. The base on this middle one is still 10, and I'm not going to write that in every time. I just want you to make that connection that a common log always has a base of 10. So log base of 10, and I'm going to rewrite 100 as 10 squared. That would be 2. I can rewrite this as the log of 10 cubed, because 1,000 is 10 cubed. The logarithm there would be 3. Hopefully right about now you're starting to see a pattern. If it is a common log, I'm going to stress that again, common log, however many zeros is going to be your answer. However, rarely are you going to get nice, pretty integers as your answer. You're usually going to have some other things going on, and we're going to get to those shortly. Well, as I said, exponentials and logarithms kind of are inverses of each other. They undo each other. And what we can do is, if something is written in exponential form, we can rewrite it in logarithm form. Depending on the problem, sometimes it's going to be easier to solve in logarithmic form. Sometimes it's going to be easier to solve in exponential. Right now, we're just going to practice writing them back and forth. So if we've got log base b, and we want to, that base is that little small subscript of some number equals a, we can rewrite that as x equals b to the a. Well, in this case, we're given the exponential form, and we want to write it as a logarithm. So that would be log, and my base is going to be 9, of 81 equals 2. Here, I'm taking the log, my base is 4, of 1024, and that's going to equal my exponent, which is 5. Don't be worried if you see something with fractions or negative exponents. They are going to happen. You treat them exactly the same. The log, and my base now is 1/3 of 9. It's just going to equal my exponent, which is -2. The log, and my base is 2. And your base is always going to be the number that's with your exponent of 512. You don't have to put parentheses. I'm usually in the habit of it because it looks a little neater. Equals 9. Yep, I got everything on that page. Okay, well, we're going to use our knowledge of that to evaluate some logarithms. On the first one, I've got log base 4 of 32. A little bit later in the chapter, we might learn an alternate way to do it. This is how we're going to do it so far. Well, I'm trying to figure out what it equals, so I'm going to set it equal to some variable. Last time, we took and wrote them from exponential to logarithmic form. Right now, I'm going to take from the logarithmic form and write it exponentially. So I would have 4 to the x equals 32. And I'm going to think back to previous lessons. When we had an x in the variable, I would try and rewrite them using the same base. 4 can be rewritten as 2 squared. 32 can be rewritten as 2 to the 5th. I have the same base, so I can set my exponents equal to each other. 2x equals 5, or x equals 5 over 2. So if I were going to evaluate that, it's 5 over 2. Let's do another one. Let's set that equal to x. Now I'm going to rewrite it in exponential form. 2 to the x equals 128. 128 can be rewritten as 2 to the 7th. Therefore, x equals 7. Set it equal to x. 9 to the x equals 27. I'm going to think of a base of 3. Every once in a while I'll have a student who will say, why can't we just divide by 9? Because they have different bases. It will not work out. 9 can be rewritten as 3 squared. 27 is 3 cubed. They have the same base. 2x equals 3, or x equals 3 over 2. Let's make that 2 a little bit better. Here's my answer. All right, we've got log base 2 of negative 32. Just like before, we're going to set that equal to x. 2 to the x equals negative 32. In class, I let people suffer with this one for a little bit. I'm just going to tell you right now, you cannot take 2 to any number and get a negative. There is no answer. What that really means is you cannot take the log of a negative number. Make a mental note of that. You cannot take a log of a negative number. It will be undefined. You will get an error in your calculator if you ever try. Let's try one with fractions though. Set it equal to x. Rewrite it in exponential form. I know that 1/3 is the same as 3 to the negative 1. 1 over 9 is really 1 over 3 squared, which is 3 to the negative 2. Take your exponents, set them equal to each other, and we can do that because we have the same base. X is 2. All right, now we're going to talk about the natural log. We've talked about the number e And what the natural log is really just log base e. But we never write log base e. What we're going to do is just write the natural log. So this log e is the same thing as natural log. I don't know if you guys can hear that, but music just started playing in this room. I'm going to have to pause it for a second. And the music has stopped. So log base e, we don't write it like that, we'll just write it as a natural log. So here, my exponent is 1, my answer is 1, 2, and 3. I think that was left over from some typo, but if you were curious, the answer would be 5. All right, that's all I have for you today. Your assignment can be found on My Big Campus on the syllabus.